would be the greatest common factor, or GCF. Can you look at this and tell me what the greatest common factor is between these two? It's a number and a letter, if that helps.
5x.
5x, good. Okay. And then what goes in parentheses is there's a couple of ways to do this. One way I've been showing students lately is you actually divide each of these by that greatest common factor. So it would be 2x plus 7. Does that look familiar to you? Something you've seen here?
Yes.
Perfect. Okay. Now I'm going to throw a much more difficult one at you because you got that so fast, and then we'll move on to something else. But this is, this is perhaps the most difficult one that you might see. Sometimes it's more than just a number and a letter. It might be two letters.
Right.
So just makes it a little bigger there. Okay.
6m squared n squared.
Good. Okay. And then to figure out what goes inside parentheses here, you could divide each of these by that. Can you tell me what would go in parentheses as a result of that?
Yes. 3n squared.
Okay.
Minus 2 n.
Good.
Plus 4.
Like
yeah.
that?
Mm-hmm.
Good. Okay. All right. Now, do you know if this right here is factorable? Or do you know how to tell if that's factorable?
I don't know.
You don't know. Okay. We will get to that a little later today in our factoring. Okay. So the next type of factoring that you might be asked to do is trinomials. So I'll just throw a couple of problems here at you. See where you're at on this. Okay, how about, do you remember how to factor something like this?
Yes.
Okay. So I'll help her a little bit. You're looking for two numbers that multiply to 24, the last number, but add to negative 14.
Right. 12 and 2.
So those satisfy the first condition, the 24, but they add up to positive 14, not negative 14.
Negative 2 and negative 12.
Yes. Very good. Okay. All right. So now let me give you a new problem here. A new example here. So let's say it's 3x squared minus 12x minus 36. You might think that this is kind of like the previous one in some ways. Not sure. It is a trinomial. Okay. But the first type of factoring that you always try is the GCF. Okay. Is there a greatest common factor here between these?
Yes.
Okay.
3.
And what is that? 3. And the reason you do that is it makes the next factoring easier. So I'd like you to try factoring this trinomial here. Two numbers that multiply to negative 12 but add up to negative 4.
Okay. 2 and negative 6.
Okay. So what goes inside the parentheses? What you said is correct, but I want to see if you've got the full understanding here of how to proceed.
You do x plus 2 and then x minus 6.
Perfect. Okay. So final problem here for you to try before we move on to something else. Let's go minus 5x squared minus 20x plus 105.
So you can factor out 5.
You can actually do a little bit more than 5. You almost never want the x squared to be negative, so you would factor out -5 from everything.
Okay.
Okay, so why don't you take it from here? Why don't you figure out what goes in here, and then see if you can factor that part that's remaining.
Okay. Okay, so -5 times x plus 7 times x minus 3.
Okay, now to check this, what I can do is I can FOIL. So I get x squared minus 3x plus 7x, that's plus 4x minus 21. And if I multiply those by -5, you get -5x squared minus 20x plus 105. Very good. Okay. So I would say that based on the few examples that we've done today, that you do really understand your factoring, but I'm going to throw just a few more questions at you because they do get a little bit more difficult, and just see where you're at. So here's a type of problem: 3x squared plus, sorry, I already wrote the wrong one down. 2x squared minus 5x minus 3. Okay, and the instructions, they would say to factor this. All right. Now, unlike the previous problem, there's no GCF. There's not a number or a letter that goes into all of these.
Right.
Okay, which means that there's another technique that you might use. So there's a couple of options here. One is guess and check, which I guess really isn't taught much anymore. It does work well for this problem because there's only one factor of 2. The other is to take the 2 and the -3 and multiply those together. My guess is that's what you've seen in class for something like this. Is that right?
Yes.
Okay. So this 2 and this -3, you multiply together, and you're like, all right, that's -6. But why am I doing that? Well, you need 2 numbers that now multiply to -6, but add up to -5. So 2 numbers that multiply to that, but add up to -5. Can you tell me what those would be?
Is it -6 and +1?
Yes. Okay. Now, the idea is that this -5x is replaced by -6x plus 1x. Okay, and from here you have the appearance of 4 terms, and you're going to use what's called factor by grouping.
Right.
Does that sound familiar?
Yes.
Okay, so factor by grouping, you look at the first 2 terms, and you determine, well, what's the GCF? What's the GCF of just the first 2 terms?
2.
A
2x.
little more, 2x, yeah, 2x. And then inside parentheses here, it's x minus 3. Now, very important is that you immediately write that x minus 3 over here to the right. You don't waste any time overthinking it. And so now you figure out, well, what number goes here such that when you multiply in, you get back to the previous line. In this case, it's 1 or plus 1.
Right.
Okay. Now, I actually prefer the name double factoring because you actually end up factoring at least twice, twice a lot of the time, we'll say, because you're not done. Like this line right here is not done. There's an x minus 3 in both of these. And so you factor that out, x minus 3, and then what's left over is the 2x plus the 1. Is there anything about that that is unclear to you or that you need a little bit more review on?
I think I got it.
Got it?
But
Okay.
for the step you wrote in blue, why
Yes.
do you do the x minus 3 right away in the second equation?
Because that's what you're hoping you can get out of the previous line. You're hoping like if you were to go backwards, you could get to the previous line here. Like if like 1 times x gets you back to x, 1 times minus 3 gets you back to that. This is the technique that's used. So maybe I'll go through one more example with you before I have you try one on your own here to answer that question better. I think this one will.
Mhm.
That's not, yeah, maybe. Okay. So the next one here is 2x squared minus 3x minus 14. So you first say, oh, there's no greatest common factor. 2, -3, -14. There's no greatest common factor. I can't combine those. So I'm going to take the 2 and multiply by minus 14. That's minus 28. Okay. And then you say, well, what two things multiply to minus 28, but they have to add to -3. They have to add to -3. If you think real hard, it's 4 and -7.
Okay. Okay.
And I'm trying to, I'm just trying to see if this one doesn't actually give us the situation I was hoping for, but that's okay. So this is 2x squared plus 4x minus 7x minus 14. Okay. So now you look at the first two terms and ask yourself, what is the GCF there?
2x.
2x. So 2x, and then what goes inside the parentheses when you factor out a 2x from each of these?
X plus 2.
X plus 2. And I've said this now. Now I'm going to give you the reason this goes here is because we're going to find some number that when you multiply in, you get back to the previous line. If you cannot do that, if you cannot do this step, then it is prime. But you should be careful that you hadn't made a mistake, like a sign error or something as well. So sometimes it's easier to look at the constant. What do you multiply 2 by to get back to minus 14?
Minus 7.
Yes. And is minus 7 times x minus 7x?
Yes.
Yes. So now this is the double factoring part. Both of these, like if I were to write it a little nicer here with a little better spacing, you would see that there's actually only 2 terms. There's this one on the left and then this one on the right. They both have an x plus 2. So you take that out. And what's left over? What's left over is the 2x and then the minus 7.
Got it. Okay.
Okay. So I'd like you to do at least one on your own here. So let me snip that in. And you're welcome to ask questions if anything is unclear, but give this a try and see what you come up with.
Okay. Okay. X plus 4 times 3x minus 2.
Like this?
Yes.
Okay, it's looking pretty good here. 12x, yeah. So that does work. Did you follow the approach that I recommended?
Yes, I did.
Okay, because you can also guess and check, and this one does work out pretty nicely. Okay, so let me disguise a few problems here just to see if you know how to tackle them. I'm not gonna make them super difficult, but I want to see if there's any gaps there. So let me try this one. Let's say I wanted you to factor x cubed minus 4x squared minus 32x. What would you do first for this one?
Um, would you do you factor out x first?
Yes, you always look for the GCF. Like that's the most important thing I've said. X squared minus 4x minus 32.
And then do you split the 4x into
Not for this one. There's a 1 in front of x squared. So whenever there's a 1 in front of x squared, let me go back and show you. It's a problem like this where you'd look at the last number. It's only when you can't factor out that number in front of x squared that you do this break apart approach.
okay.
So just to be clear here, you're looking for now for two numbers that multiply to minus 32, but add up to minus 4.
Uh, minus 4 and minus 8.
Give me the final whatever it is here.
X plus 4 and x minus 8.
Yes, very good. Okay. All right, so I think you've got a good understanding of it. So let's talk a little bit about what are called perfect square trinomials.
Okay.
Okay, so the following is a perfect square trinomial, and maybe you can tell me why if I could find the one I was trying to get pulled up here. There it is. Let's go x squared plus 10x plus 25. Any idea why this might be a perfect square trinomial?
Because the first two both have x and the last two both have 5.
Okay, we're kind of on the right direction. Give me the two numbers that multiply to 25 but add up to 10.
5 and 5.
So this would be x plus 5, and these are the same. So the way that you would write this is x plus 5 squared. And this is the whole point of the perfect square trinomial. So there's three terms, but it's the square of the same two terms.
Okay.
Now so maybe you can pattern this. Like why did I put a 5 down there?
The 5 from 25.
Yeah. So it's the square root of 25 is 5. Okay, so let's try another one here. Let's say I give you something like x squared plus 8x plus 16. What would this be as a perfect square trinomial?
X plus 4 squared.
So x plus 4 quantity squared like this.
Yeah.
Good. Okay. Now we can get more difficult than these, but I guess I would have to know if that was something. Do you know if perfect square trinomials were covered in your class?
They were.
They were?
Mhm.
Okay. So so the x, just so the x right here, and this is really important. The x comes from the fact that the square root of x squared is x. And the 16, or the 4, comes from the fact that it's the square root of 16. Okay. So
Yeah.
for example, I can give you something else. I can do 25x squared plus 60x plus 36. And if I tell you this is a perfect square trinomial, okay, what that means is you have to take the square root of 36 and the square root of 25x squared, and that tells you what goes in parentheses down here. Can you do that for me? Can you tell me what goes in parentheses?
Is it just 5x?
Okay, and then
6.
plus 6. Yeah. Okay. Now the reason this works is you can always check this by going back and foiling, and you don't need to do this, but that is how you would verify. But there's something very important about this middle term that we'll get to in a moment. Let me give you one to try here on your own. Let's go 49x squared plus 14x plus 1.
Okay. This one, you find the square root of 49x squared and 1.
Yes.
So 7x plus, is it 7x plus 1 or 7x plus the square root of 1?
Well, what is the square root of 1? And you just said it.
1.
1. Yeah.
Okay.
Okay. Now there's a little more to this. I'm just kind of easing you into this topic. It is also the case that it could be something like this: n squared minus 14n plus 49. Okay. So this is also a perfect square trinomial. All right. Now the square root of n squared is n. The square root of 49 is 7. Okay. But this is actually n minus 7. The minus comes from here.
Okay.
Okay, so there are actually two perfect square trinomial types. The first one is the one we've been doing all along, where see the plus comes from there, that middle one. This plus from the 60 comes from there, and the plus from this comes from there. But it could also be the case that it is minus plus. When it's minus plus, you grab the minus from here.
Okay.
Okay. So if I give you a problem like this to try on your own here, 4y squared minus 20y plus 25, and I do tell you that this is a perfect square trinomial, can you tell me what this factors into, please?
Yes. 2y and minus 5.
Yeah. Okay.
Okay.
Good. Let me give you one more to think about here. Now I'm being kind here by telling you that these work. We can get to some exceptions here in a bit, but this is good practice. This is also another kind of it's not an exception. It just is framed a little differently. But give that a try, please.
Okay. Um, 9 minus x squared.
Yes. Very good. Okay, so you got those down. Did you cover difference of squares in class?
I think so.
Okay, so that would be something like this, x squared minus 16. Okay, so this has the form of a squared minus b squared. And it always produces a minus b times a plus b. And to answer this, to factor this correctly, you just have to reduce, in this case, 16 into some number squared, which is 4. So your a is x and your b is 4. And you can write this as a minus b, x minus 4, a plus b, x plus 4. So the key to doing the difference of squares is always figuring out what is it that's squared, what is it that's squared, what is it that's squared. That is the key thing there.
Right. Okay.
Okay, so let me give you a pretty basic one here to start with. Let's just have you try x squared minus 121. What does that factor into? That's not 121. That is. Yeah. Whoops.
X minus 11 and x plus 11.
Very good. Okay, now it's so now they get more difficult. Like either of these could be squared. So for example, here's one. Let's say it's 36x squared minus 169. So you have to recognize that there's really something squared to get back to 36x squared and something squared to get back to 169. Do you know, can you tell me either of those, please?
6 and 13.
6 gets you back to the 36, but what about the x squared?
6x.
Okay. And then 13, so you would write 6x minus 13, 6x plus 13.
Right. Okay.
Okay, so let me have you try a couple here on your own. Let's go. How about this one? X squared minus 16y squared. Go ahead and try that, please.
Okay. X minus 4y and x plus 4y.
Perfect. What is the very first type of factoring that you are always supposed to do?
Greatest common factor.
Yeah, so if I give you a problem like this, and I just say to factor, you should still always look for the GCF first. So give that a try, please, and let me know what you come up with.
Okay. So you factor out 2 to 2 times x squared minus 49, and then do
Yes.
you find and then is it x minus
Yes.
7,
Yes.
x plus 7?
Yeah, so this is the synthesis. This is the putting it all together. We've got a bunch of different types. Can you recognize what to do in those cases? Here is let's go. I won't make it too bad. Let's go. We'll just do this one. 5x squared minus 45y squared. Go ahead and try that one, please, on your own.
Okay. Oh my God. Sorry.
No problem.
So you factor out 5 first.
Okay, just give me the final answer.
Okay.
Whenever you're ready. There's no rush.
Uh, 5 times x minus 3y and times x plus 3y.
Yes, perfect. Okay, you're doing great. This is not like very interesting in some ways. It's just a lot of, repetition, but when you get it all down, you feel pretty good. You're like, okay, I think I know how to do this stuff. And so there's just one other type to look at here, which we kind of already have. Why am I not seeing it? There it is. Okay, so we're going to next look at some more factor by grouping problems.
Okay.
But these are already sort of grouped for you. So we'll try the first one. So one of the things like students like often, well, how do I know which one it is? And I've tried to show you that by giving you some words along the way. Difference of squares is always two terms, right?
Right.
Factor by grouping is always four terms.
Right. Okay.
And if you notice when apologies, it's hard to follow when I'm scrolling here, but let me get back up to it. When we broke apart this one, 2x squared minus 3x minus 14, we broke it apart. How many terms do you see here? Four. So that four terms is an indicator that it's factor by grouping. So you actually already know how to do this. You just look at the first two terms and you find the GCF between them, which in this case is x. And then you write that over here. This is the hardest part. I think you got to figure out what goes here such that when you multiply in, you get back to the previous line.
Right. Just y.
Yeah. And then you see that both of these have an x plus 2 in them. And then the other thing is the x plus y. All right, so let me have you try one here on your own. I'll put it just on the right side of the screen here in case you want to look at it. This will probably be our final question for the day, but let's here, take a look. All right, so give that a try, please, and let me know what you come up with.
Okay. Okay. N plus 2 times n plus 3n.
Yes. Perfect. Okay, so the good job. Just give me just a moment here. Stop recording.